Ideally, when you sit down to do a physics exam, you'll know all of the equations off the top of your head and you can answer everything. But if you've totally forgotten everything, here's a few sneaky tricks from the dark side of physics which you can use to get yourself out of a bind. This is called dimensional analysis. Say you sit down to do an exam and you get this question. There's a car travelling at 3 meters per second for 10 seconds. How far does it go? To answer this, you need to remember the equation that ties velocity, distance, and time together. But if you have forgotten it, you can still get the right answer just from the information you've been given in the question. All the information you need is here in the units. It works like this. With any equation, the units on either side of the equal sign need to be the same. But we can't remember if the equation is distance is velocity times time, or velocity divided by time. We're going to work out which one it is from the units. So we want the answer in meters. We know the velocity is in meters per second, and time is measured in seconds. So which one of these equations will give us the right units? The first equation is meters per second times a second. So the seconds will cancel out and we're left with meters. So this looks like this one's the right equation. The other equation would give us meters per second divided by seconds, which would give us meters per second squared. This is definitely not what we're looking for because the units on either side of the equal sign are not the same. So just by using the units we were given in the question, we could answer it. Units are this amazing kind of error correction baked into physics, which we can hack in a few different ways. But you can't rely on the question always giving you the equations you need. Here's another example. An object of mass 2 kilograms has a linear momentum of magnitude 6 kilogram meters per second. What is this object's kinetic energy in joules? This question does give us the equation for momentum. Kilograms is mass and meters per second is velocity. So we can deduce momentum equals mass times velocity. But the other equation we need is kinetic energy, which for this question we would just have to remember, or we're just screwed. But if you're ever stuck in a question, it's always worth looking at the units in the question to see if they give you any clues. The second dimensional analysis hack is to derive equations from the list of physical constants which you're given in most exams. Say you have this question about gravitational physics. Calculate the gravitational force F between two planets with these masses, which are separated by a distance of this, where g is the Newtonian constant of gravitation. But imagine you've totally forgotten the equation you need to use, Newton's law of universal gravitation. So what do? You go look up big G on the sheet with all the physical constants, and blam, you get this. The Newtonian constant of gravitation, G, is this, meters cubed per kilogram per second squared. Now the equation you need to use it to answer this question is baked into the units of this physical constant. So we use the same process again. We need the units on either side of the equal sign to balance out. So we stick F on one side and big G on the other, and we know that on the right hand side we need to include a couple of masses and a distance. We just need to work out how to smudge them all together. Let's start by replacing these variables with their units. Force is measured in newtons, but that's not that useful. So we can use a simple equation like F equals ma to get the units of newtons to be kilograms meters per second. On the other side we can just put the units of G that we already got. So now we need the right hand side's units to equal the left hand side's units. And you can pretty easily see that we need to multiply by the two masses and divide by the length squared. And there we have it, Newton's law of gravitation pulled out of thin air. Now you can plug in all the numbers and get the right answer. Just remember to change the kilometers to meters. This kind of unit conversion is what dimensional analysis is normally taught for, like changing miles per hour into meters per second. But there's so much more to it than just converting units. So let's carry on. Here's another hack. You can also use dimensional analysis to derive equations from other equations. In one of our earlier questions, we forgot the equation for kinetic energy. But say we remember that potential energy is mass times the acceleration due to gravity times height. We know that kinetic energy and potential energy are both forms of energy, so they have to have the same units. So we can just write these as kilograms, meters per second squared, and meters. But rearranging it slightly, we can change it to kilogram meters squared per second squared. Wow, this looks a lot like mass times velocity squared. Hey, we've derived kinetic energy and we can use it to answer the question we couldn't answer before. Although we can't. You've probably already spotted the mistake. Kinetic energy is actually a half mv squared. So we're wrong by a factor of 2. And this is the main weakness of these hacks. Any constant of proportionality gets lost because they don't have any dimensions. So any prefactors like this half, or dimensionless ratios like pi, they'll fall through the cracks. So you don't want to rely on these techniques because you will fail. But in a tricky spot, they can be really, really handy. So they're definitely really useful techniques to learn. And I love dimension analysis because the thing is, memorizing equations isn't really physics, but deriving equations really is physics. But unfortunately, for some reason, people love to test your memory in exams. So although you shouldn't really rely on these techniques in your exams, they're really good for doing proper actual physics. Speaking of proper physics, there's lots to be found over at the sponsor of this video, Brilliant.org. Brilliant is a problem-solving based website and app where you can learn physics and other STEM subjects with over 60 interactive courses containing engaging and thought-provoking quizzes, where you can learn in the best way by actually solving problems. And if you're still looking for the perfect gift for a loved one, how about a Brilliant premium subscription? Personally, I'd way prefer getting this than some sparkly trinkets. So if that sounds interesting, head over to brilliant.org/DOS, link is also in the description below, and grab a gift subscription to help your friends and family sink their teeth into some nourishing brain food. In addition, I still have an array of attractive science posters you can pick up, and if you enjoyed this video, consider subscribing and click the notification bell to make sure you don't miss my next video. Okay, thanks again for watching, and I'll see you on the next video.